Okay, how do we know whether we are supposed to multiply or divide? The number of cookies 4 people get if the packet of 32 cookies is shared, we divide that 32 into 4. The cost of paving 30 square meters at 41 per meter, we're going to multiply that cost per meter times the number of meters. If we have one of the numbers of sheets of paper in a shipment of 4,000 boxes of 5 reams, where one of those 5 reams has 500 sheets, we're going to divide. And for this one, the number of hours I can afford a plumber at that much money is we divide our budget, our fixed budget, and see how many hours that will give us. Multiplication and division are two sides of the same coin. Division can be defined as the inverse of multiplication. So you can always multiply your way to finding fours. You can see 4 times 1 times 2 times 3 times 4. It'll still work, but the quicker way will be to divide. We can use mental strategies, and some really good mental strategies include the fact that multiplying is commutative and associative. That means that I can multiply in any order. So 5 times 17 times 4 can be done like this, and I know that 5 times 4 is 20. That can make life easier. I can also use the distributive law. So 4 times 87 is the same as saying 4 times 80, because 8 is in the tens place, and 4 times 7, and then we add those together to get 348. We could also do a little bit of compensating and saying, well, what's closer to 87? Well, that's 90. So I'll do 4 times 90, but then I got to take off the 3 that I added to round that to 90. And remember, because I'm taking that off, I'm not only taking off a 3 that I took off, I'm taking the 3 times 4. So that gets a little bit more possible to make a mistake, but you still get the same answer. Doubling and halving is great. If with multiplication, if I double one and half the other, then we're going to be in good shape. So if I were to do 4 times 74, I could probably work it out. But if I want to double and half it, I will double 74 to 148. And if I double this one, then I halve that one and the other way around. So an example I used previously was we were trying to figure out if 14 is a factor of 42. So if we double 7 and halve 6, we can see that it is, because they're equal. Mental strategies for division. It's not associative or commutative. You cannot change the order of division. It will give you the wrong answer. But you can have both numbers. And the way I like to think of this one here, this example, is that 132 divided by 4 can also be represented as a fraction. And we know that if we divide the numerator and the denominator by the same, we're going to get an equivalent fraction. So 6 divided by 2, it's the same, 66 divided by 2 is the same as 132 divided by 4. And divide that in half again, I get 33 over 1, which is, of course, just 33. I can still use the distributive law. I can take the 90 and divide it by 3, and the 6 and divide it by 3 and add those two together. Or I can round up and add 3 more. But remember, those 3 have to be divided by 3 and taken off at the end, and we still get the same answer. So again, multiplication, you can switch them, but these are not equal. 20 divided by 4 and 4 divided by 20. So super important words here. When you multiply something, you get a product. So here we're using the multiplication algorithm where we multiply, multiply, multiply. And what we get here, we'll add those together, is the product. That's the fancy word. So if you ask for a product, you're going to multiply. If you're asked to find the quotient, that comes from division. And sometimes you'll get a quotient and it won't be a whole number, so you'll get a remainder there. And we did that when we used to do short division. So here are some examples. There's a couple of mental strategies that we can use here. There's often more than one that we can do. So yeah, let's use doubling and halving. So double 5 is 10. And if I double the 5, I have to halve this one, and that gives me 800. I could also distribute 5 times 100 plus, what is it, 5 times 60 plus 5 times 0. So that's 0. So 5 times 100 is 500. 5 times 60 is 300. We get the same answer. So both will work. For this one, let's do the distributive law. 7 times 80 plus 7 times 9. So 7 times 80, I know it to be the same as 7 times 8 times 10. Same thing, same dealio. 7 times 8 is 56, so that makes that 560 plus 63, and that's I'm thinking 500 plus 123, so that gives me 623. And for this one with dividing, remember we're thinking 464 divided by 8. So in my mind, I can pretty easily divide that top number by 2. I have to do the bottom number as well, so I've divided by 2, divided by 2. But we're not there yet, so I'll divide by 2 again. And then I just divide 116 in half to get my final answer. I could use the division algorithm, or I could just divide 100 in half, and that's 50 plus 8 is 58. So I took half of 100, which is 50, and half of 16, which is 8. So if we're going to use the algorithm says 5 times 2 is 10, 5 times 1 is 5 plus 1 is 6, and 5 times 4 is 20. And then I leave a 20 here because in essence, I am doing 412 times 5 plus 412 times 20. So that's what I put my 0 there to save my space. I don't care about this guy anymore. 2 times 1 is 2, 2 times 4 is 8, add them together, 0, carry the 1 here, 10,300. And then if we're going to divide here, we have our dividend and our divisor. So this is a little bit of a tough one. So with this one, we're going to take our calculator and we're going to see, we've got 13. We're going to find that 13 goes into 93 7 times, because I just guessed, you can use your calculator, because 7 times 3 is 21, 7 times 1, 2, 3 is 91. So we put it there, remember, because we're sort of imagining our 0 there, because it's 13 times 90, 13 times something gives me 93, not 9. But we're big kids now, so we're not going to keep that there. And then that gives us a remainder of 2. 13 goes into 28 2 times with a remainder of 2. Or we could say 72 and 2/13, because that's what that remainder means.